All right. So today we're doing a whole bunch of stuff having to do with square roots and looking at some more intricate items with square roots that you haven't heard of before. Trevor, what's square root of 49?
7.
Brilliant. Why?
Because 7 times 7 equals 49.
Correct. Okay? Because you got something times something, right? Equals this. And the only thing that makes sense would be 7. Or, what else would have worked? Typically we think in terms of positive, but can I also say negative 7 times negative 7 will also get me 49? Okay, so it could be positive or negative 7. We know that pretty well. What's the square root of 81? For the same reasons. Noah?
9.
Could be 9 or it could be?
Negative.
Could be negative 9 too. Right? Either one of those would work. This one's a little bit trickier. Here's where we start getting into slightly different items having to do with square roots. What's the negative square root of 25?
5.
What?
5.
No.
Negative 5.
Yeah, really what we have here is a negative 1 times the square root of 5, or 25. Well, square root of 25 is 5, and so really it's negative 1 times 5, which is a negative 5. Okay? One more kind of like that with a negative thrown in, or actually a fractional piece thrown in. What's the square root of 9/64? I don't think we've done much with fractions inside the radical before. Can you guess what this is going to be or how we're going to solve this? Yeah.
3.
Why do you get 3/8?
Can I get the square root of 9?
Yeah, so whenever you've got a fractional piece inside the radical, it's the same as just the numerator being a radical or the denominator being a radical. Square root of 9 is 3. Square root of 64 is 8, so 3/8. Couldn't that be negative 3 over negative 8? Sure, but still those are then going to cancel out, so you eventually end up with just 3/8. Are we good with that stuff? All right, switching gears a little bit. What we haven't seen here, let's do this. Something times itself is going to get me up to 64. What could go in there? Trevor?
8.
8, right? 8 times 8 is 64, and so therefore we've said something like this. We've said the square root of 64 is 8, right? And we've just left it like that, except for we could actually have put a little 2 right there to show that it's the square root. In other words, there's 2 of these that we're taking the same number times itself. But this could actually change. Okay, so here's what I'm talking about. Can you think of a number, something, times itself again, that would get up to 8? Yeah.
2.
2. 2 times 2 times 2 gets me up to 8. Now I can't say that the square root of 8 is 2. Because I took it not just twice, once, twice, I took it 3 times. What I can do is put a little 3 here. And the way I would read this is the cubed root of 8 is 2. Because 2 times 2 times 2, that's 3 times, gets me up to 8. Does that make sense? Let's take a look at a few more kind of like that. If I have the cubed root of 125, what that really means is something times itself again, so a total of 3 times, will get me up to 125. What needs to go in there?
5.
Yeah, 5 times itself is 25, times itself again gets me up to 125. Okay? I'll have you guys do these two on your own on a piece of paper. What is the cubed root of negative 8? And what is the, oh, here's another one. The fourth root of 81. Can you see how that pattern still works? Take a minute to try to figure that out now. Give you a hint on the first one in case you're struggling, since I've got a cubed root that That means I'm having something times itself again, 3 of them that would multiply up to negative 8. What has to go there? Trevor, you got that one?
-2.
Get that? -2 times itself gets you a -8. Okay, and the last one, same thing. If you haven't figured it out yet, a 4th root means I'm gonna have 1, 2, 3, 4 of the same number multiplied by itself. It's gonna multiply up to 81. Get it? 3. Okay. 3 times 3 times 3 times 3 will get me to 81. There's another answer that we could have there too.
Negative.
Yeah, it could be negatives, because all those negatives would eventually cancel out and become that positive 81. Make sense? Okay, so we're going beyond just square roots, but cubed root, fourth roots. We could do that, take something to the 5th root or the 6th root or however many times we need to. And now we're going to take yet another step, and I'm going to show you another way that we could write this. Okay, so we know that 5 times 5 is 25, and so we've kind of gone backwards from that. We've said that means that the square root of 25 is 5. Okay, but instead of calling it a square root, and we could put the little 2 in here if you really wanted to, right? Another way to write that would be to have 25 be your base and raise it to a power of 1/2. Okay, so 25 raised to the 1/2 power is the same as the square root of 25. So all together, this is 5. I don't think we really like to see it in those terms, do we? Okay, so if you see something raised to a fractional piece, you probably want to rewrite this and say, well, I know that's the same thing as 25. Or square root of 25. The reason it's a square root is because of this. If we change that to something else, for example, if I have -343, and I'm going to raise that to the 1/3 power, and I say, well, raising to a fraction is the same as using a radical, except for in this case, I'm going to get rid of this stuff. In this case, it's not a square root, but it's a cubed root. So really another way to write this is the cubed root of -343, which again means what times itself 3 times gets me to -343. Make sense? Can you do that in your head? What times itself gets up to 343? That's kind of tricky, isn't it? With a larger number like that, you'd have to do a lot of guess and check. Be like, well, 10 times 10 times 10, is that too much, too little? That's way too big, right? So maybe you try like 8 times 8 times 8. You kind of have to guess and check. Take out your calculator. There's a button on your calculator that does allow you to do these different roots. So cubed root, 4th root, things like that, and get there much quicker. We obviously need to know what that means. And bring my calculator in with me. All right, so turn it on. There's really a couple ways that you could do it. Just go ahead and clear it. So if you plug in, go ahead and put in parentheses, -343 parentheses. You could raise it to the 1/3 power. So it would look something kind of like this. Okay. Actually, I think you need to put that 1/3 in parentheses as well. -343 raised to the 1/3 power. Yep, -7. Or the other thing that you can do where do we go for that? that was one of our. I gotta find that. Alright, I'll come back to this later, I've gotta look for it, but you can actually plug in a third, radical or fourth radical or something like that. I thought that was on the main panel, it's not, so I'll have to dig in there and find it a little bit later, okay? Alright, two more for you to use. Try 81 to the 1/4 power. Before you start plugging it into your calculator, what's another way to write that as a radical?
81 to the fourth.
Not 81 to the fourth.
Not the, fourth root.
Yeah, the fourth root. So it looks like that, the fourth root of 81, which really means something times itself, times itself, times itself gets me up to 81. That one you could probably do in your head. I think we already did this one, didn't we? Yeah, 3. So go ahead and plug that in your calculator for practice as well. 81, and then that little caret symbol raised to the 1/4. I think you need to put them both in parentheses. And then try one more. Negative 625 raised to the 1/4 power. What's another way to write that? Yeah.
How do you put it into the fraction? How do you write a fraction?
Just 1 divided by 4, as long as it's in parentheses.
Oh, okay.
What's another way to write negative 625 raised to the 1/4 power?
Negative 625 to the little 4.
No. I don't think, unless you're just saying, you might just be saying it wrong. We would say the fourth root of.
Oh, yeah.
The fourth root of negative 625. Go ahead and try to plug that in your calculator. What do you get? Something times something times something times something gets you a negative 625. Did it say anything when you plug negative 625 raised to the 1/4? Yeah.
It said non-real answer.
Not a real answer. I was thinking it might say something like error. Why not? Why can't I say take something times something times something times something to get me a negative 625? I'll tell you what, you'd have an answer if this was raised to the third power, or the third root. You would have an answer if it was the 5th root or the 7th root. But you can't do the 4th root or the 6th or the 8th.
Because 4 to
Think about how positives and negatives multiply. Right? I can't take a negative number times itself 4 times. It's going to become positive. I can't take a positive number multiplied by itself 4 times. It's going to be positive. But whenever you take an even number of something, all negatives or all positive, it's going to be positive. Right? So I'm not going to have a solution that would fit in there to get me a negative number. Okay? One last one. You tell me how to do this. A gift box in the shape of a cube has a volume of 3375 cubic inches. What's the side length of the box? In other words, how many inches is that? It's going to be the same as how many inches is that, right? And how many inches is that? Because it's a cube, they're all the same. How am I going to figure that out? Yeah.
15.
Did you say 15? How?
I did 3,375 times 1/3.
Times 1/3?
Yeah. Well, like, times the power.
Okay, so you got it right. You're saying it verbally wrong. Because if you 1,375 times 1/3 is going to give you like 1,125. That's not what you meant. You said you're going to raise it to the third power. Okay, or another way to say that would be taking the cubed root of 3,375, right? And the reason that we're doing that is because really we have an s times an s times an s. So s cubed will get you that 3,375. If I'm trying to solve for just the side length, in order to get there, I have to take the cubed root of this side. And if I do that to one side, I have to do that to the other side as well, so you're right. Whether you wanna write it like that or like that is fine. You got 15, you said? Okay, so 15 inches, and you could double check that by saying 15 times 15 times 15, does that really get me up to 3375? Yeah, it does. Sound good? So we've done a lot of different applications of radical numbers. We're gonna have a little bit of practice with that today. So we're on lesson 50. Is this you? Nope, I'm on the wrong one. So you guys today have, jumping around a little bit, numbers 3 through 17, and then 25 through 30. You got some time right now, you can start on that. Let me know if you have questions.